best now. Got the keys, we the best now. Ayy.
Good day, guys, and again, welcome back to another trigonometry lesson. Still on grade 11 lesson. So today we're going to deal with reduction formulas. Reduction formula. So we're on reduction formula today. So let's just take a look back at what we used to do in grade 10. So in grade 10, mostly we're focusing on acute angles. When we say acute angles, we mean angles that are less than 90 degrees. So all the angles that we're dealing with, they were less than 90 degrees. So now we are going to deal with angles that are even greater than 90. So we're going to deal with obtuse angles, or even more than that, or reflex angles, right? So we are going to use the Cartesian plane to help us to reduce those angles. So what we use to reduce those angles to be acute, we use the reduction formulas, right? We use reduction formula. They're the ones that we use. So reduction formulas are designed such that when you use them, the angle meaning doesn't change. The meaning of that angle doesn't change. It remains the same, right? So we have reduction formulas in the first quadrant, in the second, in the third, and in the fourth quadrant, right? So I'm going to show you how we can use these reduction formulas. But don't forget that counting the angle in anti-clockwise direction, it is positive, and in the clockwise direction, it is negative, right? We talked about that in previous lessons, right? So let's try to understand this, and also let's try to use these reduction formulas, right? Yes, let's just dive straight into it. So let's try to take a look at this Cartesian plane. So this is our first quadrant, second quadrant, third, and fourth, right? So first, second, third, and fourth. And don't forget that we're having this situation where all are positive, sine is positive, tan is positive, and cos is positive, right? So what happens is that, as I said, if we are counting anti-clockwise, we are adding, right? So this is the zero line. So any angle that is any movement from this line, it means that we're going to have our angle theta like that in the first quadrant. So in the first quadrant, our reduction formula is theta, right? And now I'm avoiding using 90 minus or 90 plus. I'll explain them later on. Firstly, let's deal with these ones that that are not complicated, right? So in the first quadrant, it is theta, right? But try to take a look at this. If this angle increases, right, and then gets to maybe the second quadrant like that, so that angle has increased and moved from there to come to this side. So it means that now our angle will be like this. This will be the whole angle like that, right? So to avoid using a bigger angle, we can just say, okay, we can have 180 minus theta. Can you see that? So 180 minus this will be equals to that. So it means that in the second quadrant, we can just use 180 minus theta as our reduction formula. And it also makes sense that from here up to it is 180, and if you just subtract like that, it just becomes 180 minus theta, right? And then in the third quadrant, now that we've passed this 180 line going to the third quadrant, so it means that any angle that will be in the third quadrant, it will make sense that it is 180 plus theta, because angles in the third quadrant, they are bigger than 180, right? They're bigger than 180, so we can use 180 plus. And angles in the second quadrant, they're smaller than 180, so that's why 180 minus. So these reduction formulas, we're going to use them a lot, but don't worry, I'll show you how to use them. Don't worry. And then when we get to the fourth quadrant, again, let's avoid using this 270, because 270 and 90, they're having the same effect. They change, right? So for now, let's just try to use the ones that I gave you. So when you get to the line 360 and we are trying to move backwards, don't forget that I said moving and clockwise we subtract, and moving clockwise we add. That's why when you go to the line 180 and we're trying to move backwards, we said minus, because moving backwards it is subtracting, or moving clockwise direction it is subtracting. And it also makes sense that when you go to the 180 line, we added like this, because going anti-clockwise, we are going to add the angles like that. So it means that also when you go to this line, the 360 line again, it means that we have made the revolution like that, right? So it means that any angle that will fall here, it will just be 360 minus theta. So this is 360 minus theta, right? So this is the reduction formula in the what? In the fourth quadrant. And as well, we can just say minus theta, because if we just subtract an angle, it falls in the fourth quadrant, right? And also, so again, when you get to this 360 line and then decide again to move that way, it means that also in the first quadrant, our other reduction formula, it is 360 plus theta, right? Like that. I'm going to show you how to use these guys, so don't worry much, right? So let me just make a table that can represent which reduction formula to use and in which quadrant, right? So let's try to take a look at these guys. So in the first quadrant, you know that first quadrant ranges from 0 to 90 degrees, second quadrant from 90 to 180, third quadrant from 180 to 270, and then the fourth quadrant from 270 to 360. What I'm trying to say is this, guys. So it's 0 to 90. This gives us the first quadrant. 90 to 180 gives us the second quadrant. And 180 to 270 gives us the third quadrant. And then 270 to 360 again gives us the fourth quadrant, right? So now, in this situation, it means that any angle that is from 0 to 90, it falls in the first quadrant. So our reduction formula that we're going to use is just theta, right? In the second quadrant, our angles run from 90 to 180. So any angle that is between 90 and 180, it means that it falls in the second quadrant. So we just use the reduction formula 180 minus theta. And then in the third quadrant now, they run from 180 to 270. So it means that we just use the reduction formula 180 plus theta. And in the fourth quadrant, the angles, they run from 270 to 360. So we just use 360 minus theta. And alternatively, if we're having an angle that is way bigger than 360, then it means that it is in the first quadrant, and you can use 360 plus theta. So it means that this situation will be in the first quadrant, right? And lastly, in the fourth quadrant, again, if you're given a negative angle, it means that initially it is starting in the what? In the fourth quadrant, if it is negative. So you just place it in the fourth quadrant. And again, having said that, don't forget what you have learned already. So don't forget that here all the ratios are positive. And here in the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And lastly, in the fourth quadrant, only cos is positive. So it means that with this situation that we're given, again, be mindful about your quadrants, right? So it means that only in the second quadrant sign is positive. So if you're having any angle that is falling in 180 minus theta and the ratio is cos, it means that in the second quadrant cos is negative, something like that. That's what we're going to do. So let me give you the examples on how to use the reduction formula, and trust me guys, this is very, very simple. Just pay a bit of attention and everything will be okay. So let's try to take a look at this one, guys. So we're having here, this is saying 180 plus x, and 180 plus x, this is the reduction formula, and we said this reduction formula falls in which quadrant? This falls in the third quadrant, right? What about this 180 minus? It falls in the second quadrant. 180 plus in the third quadrant. 180 minus in the second quadrant, right? And then this is just x, so it means that it is falling in the first quadrant. So now let's deal with this. So in the third quadrant, you know that cos is negative, because only tan is positive in the third quadrant. So this is going to give us a negative ratio of cos x. So it means that having put this together like this, we are just going to ignore this reduction and just take the angle like that. So this is just cos of x, but it should be negative because in the third quadrant cos is negative. Multiply by, and then this is tan 180 minus x, and we said it falls in the second quadrant. And tan in the second quadrant, it is negative, so we're just going to include negative tan of x. And now we're having this 180 plus, it is in the third quadrant, and sine is negative in the third quadrant. So this is going to be negative sine x, right? And then now this is in the second quadrant and sine is positive in the second quadrant, so we're just going to take it as sine of x, right? And then x on its own, it is in the first quadrant, so it means that our sine is positive in the first quadrant, and this will give us sine of x like that. So already we can see some of the things that we can cancel out before going anywhere, right? So we can cancel out the negative and the negative, and also sine and sine there, right? So it means that now we are having negative cos x multiplied by, on the previous work we already shown that if you're having tan of x, we can change it into sin x over cos x. So this is sin x over cos x all over sine of x, right? So this and this can cancel out. Now we're having negative sine x over sin x. So this is negative sin x over sine x now. And sine of x and sine of x can now cancel out, and we can be left with negative 1 is our answer. Just like that. Can you see that? So this is how we can deal with this. Very simple, right? So let's take a look at another example, guys. So let's take a look at this one, guys. So what do we have? We have 180 plus x, and this falls in the third quadrant. And negative x, I said if the angle is just negative like this, it means that it is in the fourth quadrant, and also this is in the fourth quadrant. Can you see that? So now is sine positive or negative in the third quadrant? It is negative, so we're going to say negative sine of x. And is cos positive or negative in the fourth quadrant? Cos is positive in the fourth quadrant, so this is just going to be positive cos x. And is tan positive or negative in the fourth quadrant? It is negative, so this is negative tan of x. So negative and negative can cancel out straightforward, right? Now we're having sine of x multiplied by cos of x divided by tan of x. So this is sine of x multiplied by cos of x divided by We said tan of x, it is the same as sin x over cos of x, right? Now this is the same as sine of x multiplied by cos of x multiplied by cos x over sine x. We explained that already, that if we are having a division of a fraction, it means that we are going to reciprocate and multiply, right? So now it means that this and this can cancel, and then cos x multiplied by cos x, we're going to get cos squared x, like that. Very simple, right? If I can give you the checkpoints, guys, I want to explain some of the things that they give you. Oh, so it's not always that they give you this in this way or whatsoever like that, right? Sometimes they can give you the reductions in this way. Maybe they can give you negative 180 negative theta like this as an angle, right? And we'll try to solve that. Or they can give you theta minus 180 like this. So this is not in the form of reduction. Can you see that? And also they can give you negative theta, and which negative theta we've already explained that this is in the fourth quadrant. So I don't think this you have a problem with this. I don't think so. And also they can give you theta minus 360, right? So let's just try to figure out where they fall in these angles, right? So that you won't have a problem in solving them. So one of the straightforward ways that you can use is firstly, you have to factor out the negative here, right, on this one. So if you factor out negative, it means that this, if you factor out negative, it is going to be 180 plus theta. So firstly, we deal with this negative, and then lastly, we deal with this, right? I hope I'll show you on the checkpoints, because the checkpoints that I did, they are going to have questions like this. Or what you can do, rather, you can use the Cartesian plane, right? Don't forget that I said going that way we're adding angles, and going that way we're subtracting angles, right? So if we're having a situation wherein we are having negative 180 negative theta, so let's first subtract 180, right? So if we're on this line, zero line, and we subtract 180, so this is minus 180. So it means that if we subtract 180 degrees, we're going to come here, right? And subtract theta again. So it means that that angle will be in the second quadrant. Can you see that? So it means that that angle will be in the second quadrant. It means that this is in the second quadrant. Can you see that? That is another way that you can use. And if you're having theta minus 180, so again, we're going to have a Cartesian plane. So theta only. So if we are here and we add theta, so it means that it is going to fall in the first quadrant like this. But now it is saying theta minus 180. So we're going to subtract 180 degrees and come in the third quadrant. So it means that this situation like this falls in the third quadrant, and this situation in the second quadrant. So this already explained that this is in the fourth quadrant, right? So let's try to take a look at theta minus 360. So again, if we're having a Cartesian plane like this, right, and theta only, it means that it falls in the first quadrant. But now it is saying theta minus 360. And you know that 360 is a revolution. So this is going to be like that. So it means that theta minus 360 falls in the first quadrant. So it falls in the first quadrant. Can you see how you can you can use this to come up with which quadrant is your angle falling in, right? Or maybe let me just give you an example of a situation like that, so that I can give you the checkpoint. So I'm going to leave you with checkpoint 13. So let's try to solve this one. So in this one, they said sine x minus 360 multiplied by sine x minus 180. So again, we're going to draw a bit of a Cartesian plane, right? So x, we said if we are going that way, we are adding the angles, and there we are subtracting the angles, right? So it means that now, if it is x minus 360, so first we are going to start with a positive x like that, right? And then minus 360, so it means that we are going to subtract 360 and come there. So it means that this is falling in the first quadrant. So if this is falling in the first quadrant, now it means that this becomes positive. So this is positive sine of x. And now let's take a look at this again. So this, let's see where it falls. So we are having positive x to start with, and then minus 180. So from here we subtract 180 degrees. So this should be a straight line like this. So that is 180 degrees. So this is falling in the third quadrant. So if this is falling in the third quadrant, what does it mean now? It means that now our situation is in the third, and sine is negative in the third quadrant. So this is negative sine x. So sine x multiplied by negative sine x, this gives us negative sine squared x as our solution. So I hope you have seen how we can use that. So now I'll just leave you with checkpoint 13. So I hope you enjoy, guys. If you have enjoyed, please share, subscribe, and like this video, and also comment what you think we should do to improve our work. Or if you think we are doing a great job, you can just also mention that. So I'll see you on the next session that I'll be dealing with the core ratios, guys.